Hi, in this video we will see about the MySQL directory backup. So what is a directory backup? As we know that in MySQL for every new database that we create there will be a new subdirectory created under the data directory, and in that subdirectory for every table that we create in the directory there will be a file. There will be the files of that table in that subdirectory. So in the backup process and in the directory backup process, the entire directory structure of the MySQL instance would be maintained as is. We will see that in a practical demo. Also, before we perform the backup, I would like to introduce two views which we discussed in our earlier videos: MySQL.backup progress and backup history. Uh, Backup progress keeps track of the backup, as the name suggests, it keeps track of the backup progress of the different backups that we take in the MySQL, and backup history shows the history details of all the backup jobs. So ID of the backup, and if there are any error messages, error codes, and current time and the current state of the backup, and everything we can see in the backup progress. And other details like the start LSN, end LSN, start time, end time, every other detail can be seen from the MySQL backup history. Also, before we perform the backup, we will try to understand what internally happens during the backup process. In the backup process, all the files of the instance would be backed up. The system table space data file, undo files, redo files, binary log files, and all the files of all the tables will be backed up. Before it actually performs a backup, it acquires a backup lock on the instance, so so that it keeps track of all the modifications that are happening on the database. And as we know that there are two types of tables in MySQL: InnoDB tables and non-InnoDB tables. And what happens while the backup is in progress on these tables? While the backup is in progress on these tables, and with a backup lock acquired on the instance, uh, on InnoDB tables, DML can be performed without any issues, but DDL will be blocked. DDL will be blocked on the InnoDB tables, but not on user created temporary InnoDB tables. DDL can still go ahead on the user created temporary InnoDB tables. And for non-InnoDB tables, for every non-InnoDB table, there will be a read lock acquired so that it takes a consistent backup of the entire non-InnoDB table. Flush table, table name with read lock statement, it will be acquired on every non-InnoDB table, after which the non-InnoDB table will be backed up. This is to ensure that we are taking a consistent image of the non-InnoDB table. Once all the InnoDB tables and non-InnoDB tables of the MySQL instance are backed up, then it takes a brief blocking on the logging activity so that it understands, so that it makes a note of the current InnoDB LSN and binary log position and all those details. And after gathering those details, the read logs on the non-InnoDB tables are released. And if there are any recent changes happen to the instance, those needs to be tracked as well to make the backup consistent. Once everything is backed up, the backup lock on the server instance is released, and the DB is now returned to its normal operations. And with that, the MySQL backup operation completes a success. Now let's run a full directory backup, and for that we will create few additional tables. From our earlier videos, we know that we already have two InnoDB tables. Under DB1 database, we have two InnoDB tables. Let's create a new database, and in that new database we'll we'll create two non-InnoDB tables to understand the backup process. We name that as create table T4, and engine we are specifying as MyISM engine. So we are creating non-InnoDB table with engine statement, just inserting dummy data into it. And second, MyISM engine table. This is just to show the read locks on the non-InnoDB tables while the backup process. Okay. This is my data directory. Think I already directory. Okay. This is the new database directory. And these are all the files that are created for my ISM engine tables T4 and T5, the tables that we just created now. Now let's run a backup, full directory backup. Okay, this is the command, MySQL backup. Okay, this is the command, MySQL backup, and user we are specifying as MySQL backup, and password I will specify it, and the port. And it expects we are actually backing up into directory slash backup, and the actual backup command is backup. It expects the directory where we are backing up to be empty, and for that purpose we specify with the timestamp. So what happens is, with the current timestamp there will be a subdirectory created under this slash backup, and in that subdirectory the MySQL instance would be backed up. We'll run this command. It's asking for a password. Okay, I gave the wrong password, sorry. Okay, the backup completed, fine. Full directory backup. And if you see this thing, this is the unique ID generated for this backup. Okay, if you can see here, it is starting to copy all InnoDB files. First the InnoDB table first the InnoDB table files are backed up, and you can see here starting to log the instance for backup, and then it performed our InnoDB tables under DB1, T1 and T2. Those are the InnoDB tables, user created InnoDB tables. It backed up those, and then it performed the backup of all the binary log files. And then again the server instance is locked for backup, and then starting to read log tables. And we can see here, the two tables are read locked for db2 directory. I have created under db2 database, I have created two non-InnoDB tables with my ISM engine. Before backing those, it took the read log, and it even copied all other MySQL performance schemas and all of those stuff. And then it completed the non-InnoDB tables also now. First the InnoDB tables and then the non-InnoDB tables, and then requesting consistency information, as we discussed earlier. What is the current LSN and the binary log file position, and to make a note of those details, it actually blocks the logging activity and then makes the note of those details. And we can see those details are noted here, and the consistency point InnoDB LSN is this particular value. Consistency point, and we can see from our end it took the backup till end LSN, 41729, ending with 41729, and requesting completion of the redo log copy after LSN, and it found a page which was actually modified before that LSN, and it took the backup of that page also, of the, and it took the backup of the data also which got modified. You can see the same details from the MySQL backup progress also. Let me log in and show you. Before that, let me make the note of this unique ID generated for this backup. It will be helpful to filter the data. And let me log into the database and show those details. Let us see the detail from backup progress first. Okay, this is our backup ID, and at 10:01:24 .957 it started our MySQL backup, and it took a MySQL backup is locking the instance for backup at this particular time 10:125.797, and then it MySQL backup unlocked the instance at 10:125.936. So we'll see from the log. Okay, the backup started at okay, the server instance is locked for backup 10:125, and then again at 10:125 here the fraction of the time is not shown, hour, minutes and seconds only is only shown, and then again the server instance is unlocked after 0.063 seconds, and then it performed the backup of the InnoDB files, completing the copy of the InnoDB files. Okay, you can see the first log details yeah, from the table also 10:125 and 10:125, but the table showed the fractional details also 10:125 and 10:125, no, 936. It unlocked the first lock, and then again at 10:127 MySQL backup is locking the instance for backup, and 10:127 locking tables and copying other engines data 10:127 966. Basically at around 10:127 585 it acquired the lock on the instance, and it is started the backup of the other non-InnoDB tables. Let's see from the log also. Okay, 10:127 it showed the table actually showed the fractional details also, not the log. 10:127 the server instance is locked for backup, and then it started the non-InnoDB tables also. You can see here two tables are read locked, and then it backed up those tables, and then table shows MySQL unlocked the instance at around 10:129, and MySQL backup unlocked the tables also at around 10:129.133. 10:129. Okay, 10:129. The server instance is unlocked after 1.574 seconds, and in the second lock it actually backed up the non-InnoDB tables. Two tables are read locked, and then after after backing up the InnoDB tables and the non-InnoDB tables, it blocks the logging activity into the redo logs. We can see that here. Completing the copy of all non-InnoDB files, and then requesting consistency information, and locked the consistency point for this many microseconds, and then as we discussed earlier, the server ID, GTID, binary log position, binary log file, and all those details InnoDB LSN, basically until this particular LSN and until this particular log file position, it has backed up consistently. And the same thing we can see from the logs also. the time for before it started the InnoDB tables and unlocked it, and again logged it for non-InnoDB tables and unlocked it. So as we discussed earlier, backup progress shows the different stages of the backup. That is really helpful for us to understand the timelines required for the backup. And this particular table, backup history, and for this particular backup ID, will show till what binary log file and what binary log position it has backed up completely fine. We can see the same thing from the log also. You see here consistency point binary log position 1390 and binary log file 114 till this particular LSN 729. So that completes the details about the full directory backup. So let us see the actual directory backup, how the backup would be. The backup is written in this slash backup and in this particular timestamp, since we have provided with timestamp flag. Let's go and see how the directory backup will be. 2020 11/21, that is the timestamp. We have discussed about all this meta, what is there in this meta, and what is the server my.cnf and server all.cnf in the other incremental video. What all these files we have discussed. Let's go into data directory. You can see, like, how the actual data directory would be maintained. Even in the backup also the same way it maintains everything. That is what is a directory backup. This is my InnoDB tables, and under DB2 we created the non-InnoDB tables, my ISM engine T4 and T5. And with that, let us connect to the database again and make few more modifications to the database and take an incremental backup of this. Let's connect to the database. This data is already existing as part of full backup. Let us make few more modifications. Let's insert 10, 11, 12, 3 records into each table. Okay, now let's run an incremental backup so that it should take the changes after the full backup. And the command for the incremental backup is this thing. As we discussed in our earlier videos also, you have three options to specify the position from where it is supposed to take the incremental backup. Either you specify the start LSN from where it is needs to back up the instance, or you specify the location of the your full backup, or you make use of the history table. In our previous video we made use of the directory for the incremental image backup, and for this let us make use of the history table. And this particular directory, incremental backup directory, it may expect to be empty. Let us, and this is the keyword Mysqlbackup -user password, and we are taking incremental backup. This is the keyword, and from to specify the position from where it is supposed to take the incremental backup, we are making use of the history table. And to write that backup, we need to specify the location, incremental directory. Let's run the command again. Okay, it completed the backup, and the start LSN and the end LSN. Let's go into the actual backup. Incremental directory backup is a location under slash backup. INC dear. Also, let us check few details of both the full backup and the incremental backups that we have just took from the database. Let's connect to the database instance. Let's get the incremental backup ID. Will be our incremental backup. Before that, this was our full backup ID. Let's check the detail for both IDs. This was our full backup ID. It's a full backup type and backup format is directory, and it started with this LSN and ended at this LSN. Let's run the same command for our incremental backup ID. This is a type of backup type incremental, and it's a directory backup, and it started, if you see the end LSN of the full backup and start LSN of the incremental backup, you can understand it. It started it from that particular point where the full backup completed, and it took the backup. With that, both the full backup and the incremental backups being completed fine, we will end this video. In our next video, we will make use of this full backup and incremental backup and restore our database. Thank you for watching.